We are continuing in our Statistics OER course in the unit for linear regression, and we will now work on prediction and outliers when we have data points between two variables for which we are trying to find a correlation. The process of predicting inside the x values observed in the data is called interpolation, but if we are trying to predict outside of the x values observed in the data, this will be called extrapolation. Now remember that the linear regression model is not a good predictor outside of the domain of the data. So when you are doing extrapolation, you need to be very careful and very thoughtful of whether you are making a good prediction or not. The value of the dependent variable that we estimate is denoted as y hat. So in the line of best fit that we estimate the final grade based on the third exam grade, if you remember, the line was y hat equals, let's look at it again, 4.8274x minus 173.51. And we would like to know what the y hat, that is the final exam estimated score, would be if x was 73 or 30. X is the third exam score. So here when we are predicting, instead of me trying to do things by hand, what I'm going to do is I will just enter here the x values and then copy the formula I had already coded in Excel for y hat, and that will give me the y for x equals 73 and x equal to 30. So the final exam score for x equal to 73, third exam score equal to 73, comes out to be 178.89. And the final exam score y hat, when x is equal to 30, comes out to be negative 28.7. So are these predictions reasonable? The y hat of 179 is reasonable. It is a possible final exam score because the final exam is out of 200. But the final exam score of a negative 28.7 is not reasonable, because a negative exam score is unreasonable. So why did we get a not reasonable score? The line of best fit was trying to fit the data when x was from 65 to 75. When x is 30, which is all the way to the left, really far away from our data, this line doesn't fit the data anymore. So it continues in this direction, but it is the value x equal to 30 is too far. So extrapolation is has to be considered carefully every time we are doing prediction. Let's talk a little bit about outliers. Outliers are observed data points that are far from the line of best fit, and that means that they have large errors or residuals or vertical distance from the line to the point. So if you remember in a previous video, we demonstrated these vertical distances with these red lines, and the residual equals the real y value minus the estimated y value y hat. Outliers need to be examined closely. Sometimes, for some reason or another, they should not be included in the analysis of the data, or some other times an outlier may hold valuable information about the population under study and should remain included in the data. So the key is to examine outliers. There is another kind of unusual points. They are called influential points. They are observed data points that are far from the other observed data points in the horizontal direction. That means in terms of the x value. These points may have a big effect on the slope of the regression line. To begin to identify an influential point, we can remove it from the data set and see if the slope of the regression line is changed significantly. How do we identify outliers that are not influential points but just outliers? We could guess just by looking at the graph and seeing something that lies too far from the line, or numerically we can use the 2 standard deviation rule of thumb and flag as an outlier any point that is located at a vertical distance more than 2 standard deviations above or below the best fit line. The standard deviation used is the standard deviation of the residuals, called S sub epsilon, which is described below. And you can do that visually if you draw 2 lines that are 2 standard deviations above and below the line of best fit. Any data points outside this extra pair of lines are flagged as potential outliers. So this will look like this if we had the line of best fit and we had calculated our 2 standard deviation distance, then we could potentially just sketch 2 lines up and down from the line of best fit that are this much away from the line, above and below. They will be parallel to the line of best fit, and any point that lies outside of those 2 lines, that would be visually an outlier. Now the question is, how do we find this distance? We have to find the distance. So we need to know mathematically how to calculate it. So the residual is y minus y hat for every point, and the sum of the squared errors, SSE, which is the sum of the residuals, gives us a calculation for the standard deviation of the errors as S equals the square root of SSE divided by n minus 2. We divide by n minus 2 because the regression model involves 2 estimates, x and y. So let's see if we can find that. In our usual line, we will go back in our Excel and we will try to calculate the SSE first and then the standard deviation. So here I will do error squared, and under this column I will calculate these residuals when they are squared. So equals this residual squared, and then I will just copy this, and then here I will copy the sum formula, and that will give me the SSE. That's the sum of the squared errors. And then to calculate the standard deviation, let's try to do it here. So actually let me put SSE, the label here, and then let's do here the standard deviation. And here the standard deviation will equal to the square root of the SSE, which is above me, divided by n minus 2. So n minus 2 is the number of data values that I have, either for the x coordinate or for the y coordinate. So I need here a parenthesis for n minus 2, and I will find the n by counting. I will count, let's say, the x's, and then let's subtract 2. And here is my standard deviation. So the standard deviation happens to be 16.4. Let's highlight it so that we can see it. And then to find outliers, I need double the standard deviation. So that will equal to 2 times the standard deviation that I found. And that two standard deviation quantity happens to be 32.8248. And when I look here at these residuals, I want to see if I can find any of those residuals that is greater than 32.8 or less than negative 32.8. And of all of these residuals, this top one is the one that has a distance greater than 32.8. So there is one potential outlier, and that is the point that has x equal to 65 and a final exam score equal to 175. So this is our potential outlier right here, because it had a distance, the residual was greater than the two standard deviations. If there is an outlier, we can delete it and fit the remaining data to a new line. The new line ought to fit the remaining data better. This means the SSC should be smaller and the correlation coefficient ought to be closer to 1 or negative 1. So here we have removed this point that had 65 for the third exam score in 175, and then we calculated the new line, and for the new line we got a better R squared. The previous R squared was 0.4397, and this R squared is 0.8319. So how do we do that quickly in Excel? The way to do it is to actually copy your X and Y's. Let's put them here, for example, and then delete this point, and then try to insert a new scatter plot without the outlier. Let me adjust so that I can have a minimum on the y-axis of 100 so that I can see better this line. And then if I right click on one of those points, I can add a trend line. It has to be linear here at the top, and then I want to display the equation and display the R squared. So this is the equation that you see here in the notes. 7.3878x minus 355.19. Remember that this y is y hat, and the R squared happens to be 0.8319. Now, again, we would like to find the residuals, so find errors. The errors are of the form y minus y hat. So follow the same process that you did earlier. So I went back in Excel and I calculated y hat with the new slope and y-intercept. Then I calculated the y minus y hat difference. And to make sure that I was pretty accurate, I added them up and I was expecting to see a number closer to 0. Then I squared those errors, and this is the sum of those squared errors. I used the sum of the squared errors and the formula to calculate the standard deviation, and I doubled the standard deviation. So I found the standard deviation equal to 9.275. And then I found a 2 standard deviation, distance from the line of best fit to be 18.55. And what I want to know is whether there are points that have a distance from this line greater than 18.55, either above or below. So I'm going to look at this, the residuals. And I'm looking for numbers that are greater than positive 18 or less than negative 18.55, and there aren't any. So here I see again that there are no outliers now that I have removed the outlier. So no more outliers.